Welcome back to the Deep Dive. Today, we are tearing into something that I think a lot of people get wrong, this idea that the cloud is just, this ethereal
Gives some
concept.
kind of magic.
Exactly.
Yeah.
But it's not. It has a physical address. It's concrete. It's miles of fiber optic cable. It's just giant buildings full of actual hardware.
That's the perfect starting point. We're zooming out to look at the global map, really understanding the geography of it all, but knowing where the machines live is only half the battle.
Right.
The other half, the part that really lets you scale, is figuring out how to manage everything across that massive network without, drowning in manual mistakes.
So our mission today is pretty focused for you, the listener. First, we're going to master the geography, the absolute basics of the AWS global infrastructure. We're talking regions and availability zones.
And then we pivot to strategy. The four non-negotiable factors that really determine where you should host your applications.
And finally, we'll get into the tool that stitches it all together.
AWS CloudFormation. This whole concept of infrastructure as code. And believe me, it is essential if you're operating at any kind of scale.
Okay, let's start with geography then. To really get a handle on resilience, we have to start at the top, right? With the region.
Yep, the highest level.
So when we say something like us East 1 in Virginia or you Central 1 in Frankfurt, what does that actually mean from a design perspective?
The philosophy is total isolation. I mean, a region is a completely separate geographic area. If you look at a map of them, they are deliberately placed hundreds, sometimes thousands of miles apart.
And the point of that is?
Independence. That's the critical word. If a truly catastrophic event happens, like a massive hurricane hits the entire Virginia region, the data centers in, say, Ireland or Frankfurt, they remain completely 100% unaffected. They just keep running.
Okay, so that handles the huge, big picture disasters.
Yeah.
But what about redundancy inside a single region? I know the real sort of secret sauce here is the level below the region.
Is the availability zones, or AZs.
Oh, right.
Yes. And the AZs are the absolute cornerstone of reliability. This is where a lot of people make their biggest and most expensive mistakes.
How so?
Because a region isn't just one giant data center. It's a cluster of separate, discrete data centers that are physically isolated from each other. An AZ might be one of those, or sometimes a few of them grouped together.
When you say physically isolated, what are we talking about? Are they like across the street from each other?
That's a really common misconception. No, they're not. They're often several miles apart. And crucially, they have independent infrastructure.
Yeah.
They don't share the same floodplain. They don't share the same power grid or the same network providers. This ensures that a localized problem, a power outage, a small fire, it can only take out one AZ, not the others.
So the absolute must-do, the best practice you should never ever break, is to run my application across multiple AZs within that one region.
Absolutely. The documentation is crystal clear on this. Deploying everything, your database, your servers, in just one AZ is a cost-cutting measure that almost always ends in disaster.
Because eventually, something will fail in that one zone.
It will. It's just a matter of time. Hardware fails. Things happen. And when that single AZ goes down, your whole application is dead in the water. But if you're replicated across 2 or even better 3 AZs, your application just fails over to the working one down the road. The user never even notices.
Okay, that makes the how of building for resilience super clear. But let's zoom back out. Let's talk strategy. So I know how to use AZs to stay online, but say I'm launching a new product. I've got 30 regions to choose from. How do I even start to make that choice?
And that's the moment where, the technology meets business strategy and law and even economics. You can't just pick one at random.
So you mentioned 4 factors. Let's start with the most obvious one, I guess. Factor 1, proximity and latency, speed.
Exactly. This just comes down to physics. If your main customer base is in Tokyo, but you host your servers in Brazil, every single request has to travel thousands of miles through fiber optic cables. Even at the speed of light, that introduces lag.
And that lag is noticeable, isn't it? We're not talking about minutes.
Oh, it's totally noticeable. A few hundred milliseconds is the difference between a snappy website and one that feels broken. For something like online gaming or financial trading, you need response times under 50 milliseconds.
So the rule is simple. Get the server as close to your users as you can.
As geographically close as possible. It just minimizes the travel time for the data. Simple as that.
Okay, so factor 2 moves us from physics to law. And this is where you said things get non-negotiable. Compliance, and data governance.
This might be a most critical factor of all because it can override everything else. Speed, cost, you name it. This is all about local and international laws. Think Europe's GDPR or specific rules for healthcare data.
Right. I've heard the German healthcare data example used a lot.
It's the perfect illustration. If German law says patient data cannot legally leave German soil, and many countries have laws like this, then you have exactly one choice for that data.
The Frankfurt region.
The Frankfurt region. End of story. It doesn't matter if servers are 20% cheaper somewhere else. It's irrelevant.
Because the legal risk is just too high.
The fines are massive. It's a hard blocker. You have to know where your data is allowed to live legally, and you have to constantly check because those laws change.
Speaking of cost, that brings us to factor 3, pricing. Why aren't all regions the same price? I mean, an EC2 server is an EC2 server, right?
You'd think so, but the cost of running these massive data centers varies wildly around the world.
Because of electricity.
That's a huge part of it. The cost of power in São Paulo is completely different from the cost in Oregon. Then you have to factor in real estate, local taxes, all of that.
And does it really add up? Can the difference actually, move the needle on a company's budget?
Oh, absolutely. The sources we looked at show that the exact same server, identical specs, can easily cost 10 or 20% more in a high-cost region.
And for a big company running thousands of servers, that's millions of dollars a year.
Millions. So what you often see is a hybrid approach. Companies will run less sensitive general-purpose stuff in the cheaper regions, but they'll keep the legally bound data in those more expensive compliant regions.
That's a really smart way to balance it. Okay, last one. Factor 4, service availability. Do new AWS features really not show up everywhere at once?
They don't, and it's a strategic choice. When AWS launches some brand new cutting-edge AI service, for example, they need to test it and make sure it's perfect before rolling it out globally.
So they launch it in one or two places first?
Almost always.
Yeah.
Historically, that's been Northern Virginia, us East 1. It's the oldest and largest region.
And the practical result for a developer is what?
The result is, if your new product absolutely depends on that brand new service, you are stuck with the regions where it's available. If you want it to launch in Cape Town, but the tool won't be there for another 6 months, well, your launch is delayed by 6 months. The latest tech often comes with a geographic string attached.
Okay, that's a fantastic framework. We've got the physical layout with regions and AZs, and the 4 strategic factors for choosing a location. So now we know where to put our servers. But managing all of that across, say, 5 or 10 global regions, that just sounds like a logistical nightmare if you're doing it by hand.
It's worse than a nightmare. It's impossible to do reliably. Which brings us to the management layer, to the concept that makes all this possible. Infrastructure as code, or IAC.
Specifically with AWS CloudFormation.
That's right.
The phrase infrastructure as code always struck me as a bit of a contradiction. I mean, infrastructure is physical stuff. Code is text in a file. How do you merge those two?
You merge them by making the code the single source of truth for the physical environment. Let's think about the alternative for a second, the manual way. You click through the console, you launch a server, you attach a security group.
Fine for one server.
Right. But what happens 6 months later when you need to change a setting on 500 of them? Or replicate that exact setup in a new region?
You're going to miss something. You'll forget a checkbox on server number 412, and now that one is different. It's insecure.
That's called configuration drift, and it is the absolute killer of enterprise systems. CloudFormation solves this by being declarative. You don't write instructions like click this, then type that. You write a description of what you want.
A blueprint.
A blueprint, exactly. It's a text file, usually in a format called YAML or JSON, and you just describe the end state you want.
So what are you actually writing in that file?
You're describing the resources. You'd write a block of code that says, I want one resource of type aws.ec2.instance. Then you list its properties, instance type, t2.micro.security .web access. You are literally defining your entire environment in that one text file.
So the file is the plan. What does CloudFormation do with it?
It takes that blueprint and does all the heavy lifting. It calls all the right AWS APIs in the right order to build, configure, and connect everything you described. It groups all of this into a single unit called a stack.
And that stack is more than just a list of things,
Okay.
right?
Oh, much more. It's a relationship manager. It understands dependencies. It knows it has to create the network first, then the database, then the web server that needs to connect to that database. It figures out the order for you.
And what about changes? If I need to update all 5,000 servers?
You don't touch the servers. You edit one line in your blueprint file. Then you tell CloudFormation to update stack. It analyzes the change and figures out the safest, most minimal way to get your live infrastructure to match your new blueprint.
That seems so much safer than logging into machines manually.
It is infinitely safer. And if an update goes wrong halfway through, CloudFormation can automatically roll back the entire stack to the last known good configuration. You can't guarantee that with manual changes. It gives you this repeatable, safe, predictable way to manage infrastructure.
Which is priceless when you're trying to keep, say, your testing and your production environments identical across the globe.
It's the only way to operate at that scale and stay sane.
This has been an amazing tour. We started with the physical world regions and AZs for resilience, then the 4 strategic factors for choosing where to go: latency, compliance, price, and services, and finally, how CloudFormation's infrastructure as code lets us manage it all automatically.
Right. And before we finish, let's just hammer home that one critical distinction, the one that trips people up when they think about this stuff.
The crucial knowledge check for you, the listener: true or false? Data automatically replicates between regions for safety.
And the answer is a definitive, loud, false. This is so important. Data replicates between availability zones within a single region. That's by design. But AWS is built to never move your data across a regional boundary unless you explicitly tell it to.
And we know exactly why that rule is so strict.
It goes right back to factor 2, compliance. If AWS automatically copied your German patient data from Frankfurt to Oregon because it was cheaper or for redundancy, it would instantly be breaking the law. That regional boundary is an enforced legal and geographic fence.
Which highlights this constant tension, doesn't it? The legal rules often trump technical convenience.
They absolutely do. And that leads us to our final thought for you to take away. We've just spent all this time praising CloudFormation for its amazing automation.
Right.
But the compliance discussion shows us that some of the most critical requirements are inherently non-technical. They're legal. They're manual.
So we're left with this gap between what we can automate and what we are legally required to do by hand.
Precisely. If ensuring your data stays compliant across regions is a manual, expensive legal process, you have to factor that human cost into your global strategy. So the question to leave you with is this: what other rules around data sovereignty or export controls might restrict not just where your data has to live, but where your code itself is allowed to run? And what's the real long-term price of manually auditing those boundaries every single day?
Something to think about as you sketch out your next global deployment. Thank you for joining us for the deep dive.